All right, let's talk about motors. Remember, motors are the most common mechanical device in the world. Pumps are number two because every pump has a motor, but not every motor goes on a pump. There are things that should be on the list that you're trying to identify with regard to any electrical motor. First, of course, is the type of motor that you're dealing with. Is this a motor that sits above ground, or is this a motor that goes submerged in water? Is this a motor that is on a vehicle, or is this a motor that's stationary? Is this a motor that runs on DC power, which is direct current, and that would be common for solar applications or pumps that run off of batteries. Most motors are alternating current, or AC. So once you get that defined, then that helps you narrow down where you search for information about a motor. For motors that are not submersible, that are above ground, each motor has an enclosure. And this is one thing that you want to get correct. The enclosure can have holes in it so that the air can come into the motor and cool it while it's running. That's called an open, drip-proof enclosure, ODP. Open, drip-proof, the water can still rain down on it and it will drip past those little holes that are more oriented toward the bottom. There are places where there's sprinklers, though, and they could shoot inside, and you don't want water inside the motor because that will help it short out, and we'll talk more about that later. But if you're in that type of situation, then you want a totally enclosed enclosure, and we call that TEFC, totally enclosed, fan cooled. So if you're not using the air to cool the motor, what you do is on the shaft of the motor sticking out of the back, you mount a fan, and then you have a plate over that makes the air shoot out along the walls of the motor to dissipate the heat of the motor. That's called a fan cooled. But it's totally enclosed so that there's no way that any water can get inside. Now, they're not necessarily, just because they're TEFC, they're not submersible. They're not that watertight. And they're not explosion proof. There are some enclosures that are called explosion proof, and what they mean is that if they explode, they have bolts along the circumference of the motor that will help it hold together rather than flying apart. It doesn't mean that it's impossible for it to explode. So those are enclosures. You want to get that little element right. That's one. Two, there's a frame size. Now, the frame size refers to the face of the motor that mounts up to whatever it's driving. Whatever pump, whatever fan, whatever conveyor belt, whatever it is. So there is a frame, and the motor industry has, a jillion frames. But even though there's so many, there is standards applied to those specific frames, frame numbers. The frame number refers to a standard of measurements for the size of the face, where the holes are, how long the shaft sticks out. All these things are inside that frame number. So you want to get the frame number of that motor, or the frame number required by the pump or whatever else you're hooking up to. They'll often tell you this takes a blah, blah, blah frame number, okay, for whatever pump you get, for whatever motor you get. So that's number two, the frame size. Number three would be phase. In electricity, there is what we call single phase power and three-phase power. Single phase is more common in the sense of that's the type of power in residential areas, in homes, and very small industry. Wherever you're going to have 115 volts is always single phase power. And 230 volts can also be single phase power. So it's more of a residential kind of power. And in between those major divisions of voltage, there are variations. Sometimes you'll see 110, or maybe less, and sometimes you will see 200 volt or 208. And another factor that's not so relevant if you're in the U.S., but we have 60 hertz power here. So all of those numbers are related to the fact that they are operating in 60 hertz power. Whereas if you go to some parts of the world, Japan, Africa, parts of Europe, they are on 50 hertz power, which is all you need to know is it's just a little slower. So everything's designed around it and everything works, but it's a different voltage. But anyway, many motors will say this motor can be run on 208 to 240, that whole range. And the same with the upper ranges of voltage. Three-phase is more industrial, and it's for bigger motors. You get into a certain size of motor, and single-phase just isn't practical anymore, so you have to have three-phase power. And so you definitely want to get the phase right that's being used, and that's determined by your power source, wherever the pump is located. What kind of power is available? Is it single-phase or is it three-phase? If it's three-phase, you want to get this next thing right. It's voltage. If it's single phase, you know it's 115 or 230. If it's three phase, it can also be 230 or 460 or 575. And there's others you probably won't encounter much, but it can be 230 or 460 if it's in three phase. So if it's 115 volt, it has to be single phase. If it's 460 volt, your power source, it has to be three phase. If it's 230 volt, it can be either single or three phase. So you need to find out which it is in your power source, because that not only does your motor have to be wired appropriately to match, but that affects the controls that you then also use to operate the motor. And then there's also speed, the RPM at which this motor runs. And there are some motors that are capable of running fast and slow, three-phase motors within certain ranges. But they are generally designed to have a maximum speed, or RPM. And most motors tend to be 3450, 3,450, or 3,600 RPMs, revolutions per minute. But many are half of that, just 1,800 RPM, or 1,750, 25. They're off a little bit with that, but they're generally in those ranges, right? Well, you really want to have the right speed on the motor, because that's determined by how the design of the pump that you're using. A certain design is engineered for 3450 speed or 1750. Now, there are some that are designed for either or, but you're going to get a vastly different performance based on speed. You want to get speed right. And then lastly, the obvious one, horsepower. It's always helpful to know the horsepower, and because that then is going to orient you in a certain full load amps that the motor pulls. There's always full load amps that's maybe the seventh thing that you got to be cognizant of. It's determined by the horsepower and the voltage but it's an important number to be aware of. And these are the main things that you look for on the label of a motor if the label is available and legible. You'd like to know these things. Of course, if it has a model number, then great. Go with that, and that model number may give you all this other information, hopefully. I've run into many cases, though, where that's not necessarily true. If you have a serial number, that's also very good, but it's only as good as the records of the manufacturer that made the motor. And I've run into many. You get a motor that's 10 years old, and they say, oh, well, I don't know, those numbers, serial numbers are in the archives back in Lower Sublovia, But if you got those numbers, they always help. Now, don't mistake the label on the pump to be the label that's relevant for the motor, and vice versa. The label on the motor does not necessarily reflect what the pump is. Sometimes they do. But many times, pumps and motors are bought from different manufacturers and put together. So you always want to look for any labels, whatever labels are there, and snap pictures of them, because nowadays you can simply send those in an email to your manufacturer, and it will help them identify what it is you're looking for.